You're thinking like that?
So interesting. And if moons around planet.
So we have an environmental test lab on the other side of a large shaker table. And so we will lift the spacecraft onto that table. And
Right below the science laboratory. To the right. I mean, I've been.
However, eFEMIS and ASU built and designed and built it. But until Europa Clipper uses Jupiter, however, eFEMIS and yeah, there's nothing there. So.
This is a model of Europa's surface and subsurface. And the reason why Europa's...
My sister was like,
Oh, wow.
are you from
San Diego? Yeah, yeah. The general area. So it was.
If you can talk about this mission.
Yes, Coco, we are really excited. We're getting
Bonnie, thank you so much for joining us this
Well, I'm a child of Sputnik. I was raised at the dawn of the space race.
Cuerpos como Europa, una de las lunas de Júpiter, donde hay agua. Es buscar agua en otros lugares, como por ejemplo Júpiter.
During that time to get us ready, so we're going to be doing more science, more laboratories. Came onto the mission that we're making this mission come to a reality.
Europa is a moon of Jupiter, but the surface of Europa is covered with a layer of ice. We think below that ice layer is a vast ocean of liquid water, and we think there actually could be more water there than all of Earth's oceans combined. In the solar system where we found life, we found that it seems to require liquid water. Liquid water is an essential component of life as we know it here on Earth, and so when we're looking for life beyond the Earth, we look for places that could have liquid water. And that has really informed our search through the solar system for places to look for life, and that's made Europa one of the best places to look. Europa Clipper is a spacecraft which we will send out to the Jupiter system. It will orbit Jupiter and it'll have about 50 close flybys of Europa. And on each flyby, it'll observe the moon with its suite of scientific instruments. And these include things like cameras, but also there's a radar instrument which will be able to measure not just the surface of Europa, but actually be able to sound into the interior. It might even be able to tell us how thick that surface ice layer is and where the ocean begins. And there will also be a variety of compositional instruments that will tell us something about the chemical makeup of Europa's surface, as well as the temperature of its surface. And there's even instruments that will be able to capture some of the particles that are ejected from the surface of Europa into space. Those can be ingested by instruments on board the spacecraft to measure their composition directly. If you were a human standing on the surface of Europa, you would get fried by radiation very quickly. And the same radiation also affects the sensitive electronics on a spacecraft. And so it turns out that if we had put Europa Clipper into orbit around Europa, it could only survive there for about a month. Instead, we chose to put Europa Clipper in orbit around Jupiter with these multiple close flybys of Europa. And so what that does is it maximizes our time collecting science during the close flyby, but then we get out of there on this long orbit, we get out of this high radiation zone into a location that's a bit safer, a place that has much lower radiation. And in this safer environment, we can downlink the data that the spacecraft took to Earth, we can uplink new commands, and we can get ready for the next flyby. I was fortunate enough to get to look at some of the first images of Europa that were taken at high resolution by the Galileo spacecraft back in the 1990s. And I've now been waiting for 25 years for new pictures of Europa. And I just can't wait. I've got to wait another 6 years until we get there, and then another couple years before we have our first close flyby. But I'm going to be holding my breath waiting to see those new pictures, those new high-resolution observations of the surface of Europa.
Right now, we're getting ready for some guidance, navigation, control system functional tests. And so what we do with this is we put the spacecraft in the mode as it's flying in space, and we insert simulations where necessary to let the system get the right kinds of inputs to react to. And then it just goes through its paces and interacts with the software. And with the other controllers on board, we have the sensors to tell where we're pointed, where we are, and then we have the actuators that make us move in different directions and making sure all of those work together in the right directions. So if you're a basketball fan, that point of reference is with the solar arrays installed and fully deployed, it would reach almost end to end on a basketball court. If you compare it to Statue of Liberty and set it up at the feet of the statue, it reaches up to about the crown. It's a very large spacecraft with the arrays installed and fully deployed. They're nicknamed bunny suits, and for obvious reasons, and we have to gone up that way to control the possibility of contamination of the spacecraft. We have instruments on board that are sensitive to particulate contamination. We have other instruments that are sensitive to molecular contamination, and then we have the planetary protection requirements that we have to meet in order to be operating near Europa. So all of those require us to cover. Humans are notoriously dirty in terms of all of these factors, and so we'll cover up as much as possible, contain any skin cells, hair, anything else that might be coming off of us, contain all of those inside of those suits, and it makes it for a pretty uncomfortable working environment for the people working on the floor. So over the next few weeks, we'll be getting the spacecraft ready to ship out to Kennedy Space Center. One of the main things that you'll see that we do is we remove the high gain antenna from the spacecraft to fit it into the shipping container. We get everything. We finalize all the blanketing. There's the last few tests that we want to do before we ship it out. Then everything gets ready to install it into the shipping container. It'll be much like you see it now behind me. It'll be mounted horizontally in the shipping container, and it's a container that's sized to just fit into a C-17 aircraft. And so the Air Force will do NASA the service of flying the spacecraft out to Kennedy. I am excited to be part of a fantastic team. From the early days of the mission up through now, it's been a wonderful group of people to work with at JPL, at APL, at the different institutions that have provided the instruments, Airbus Netherlands, who provided the solar arrays. Working with these kinds of teams is gratifying, energizing, very exciting. And then obviously, once we get to Europa and start getting science back, revolutionizing what we know about Europa and what it adds to our knowledge of the solar system is going to be the icing on the cake.
All ships are fine.
Zero mass.
They're all